Hey everyone, and welcome. Today we are going to talk about one of my favorite design patterns because it solves a problem that almost every developer runs into. It's called the Decorator Pattern, and it lets you add new features to your objects on the fly without turning your code into a giant, tangled mess. And the best way to understand it, I think, is by following a story.
So here's how we're going to do this. We're going to start with a very simple, clean piece of code. Then we'll see how adding new features the way you think you're supposed to leads to an absolute disaster. And that's when we'll bring in the decorator pattern as the hero of our story, see how it works, and then finally, we'll talk about when you should and maybe shouldn't use it.
You know, every great design pattern really starts with a simple problem. So let's imagine you're building a notification library. It's a pretty common task, right? And at first, it seems really straightforward.
So you start out with this beautiful, clean notifier class. It has one job, and it does that job perfectly. It takes a message, and it sends it as an email. The code is simple, it's easy to read, easy to maintain. Perfect. Job done, right?
Well, of course not. Your library is a huge success. But with success come new feature requests. First, your users want SMS notifications. Then, they want Facebook alerts. Pretty soon, corporate clients are demanding Slack integration. And then comes the big one. Users want to get notifications on multiple channels all at the same time. All of a sudden, our simple, elegant design is under some serious pressure.
Now, what's the first tool most of us reach for when we need to add functionality to a class? Inheritance, right? It's what we're taught. So let's go down that road for a minute and see exactly where it takes us. And spoiler alert, it's not somewhere you want to be.
Okay, so the most intuitive object-oriented solution seems to be creating subclasses. We can have an SMS notifier that inherits from our base notifier, a Slack notifier, a Facebook notifier, and so on. And you know what? For setting to just one channel, this actually works okay. But what about that request to send to multiple channels?
This is where the whole thing just becomes a complete nightmare. To support all the different combinations, you have to create a separate class for every single possibility. A class for email plus SMS, a class for email plus Slack, a class for email, SMS, and Slack. This is what's called a combinatorial explosion, and it is a maintenance disaster. Your code base just balloons, and adding just one new notification channel means you might have to add dozens of new classes. It's completely unmanageable.
And this is that moment of crisis. The inheritance approach is clearly not going to work. It's rigid, it's messy, and it's basically a dead end. We need a totally different way of thinking about how we add behavior to our objects. And this leads us to one of the most important principles in object-oriented design. Favor composition over inheritance. Instead of creating this rigid family tree of classes, we're going to build our functionality by, well, wrapping objects inside of other objects.
This here is the official definition of the decorator pattern from the legendary Gang of Four book. And the key word, the most important word on this slide, is dynamically. We're not locking in all the possible combinations when we write the code. Instead, we're giving the user the power to mix and match them however they want at runtime.
So what is this thing? Well, the decorator pattern, which is also just called a wrapper, does exactly what the name implies. It lets you take a core object and just wrap it with other objects that add new behaviors, almost like you're adding layers to an onion.
This slide really gets to the heart of the mental shift you have to make. With inheritance, an SMS notifier is a notifier. It's a static, permanent relationship that's set in stone when you compile the code. But with composition, our object has a notifier. That tiny change in language from ISA to HASA is what gives us all this incredible flexibility. We can add, remove, and combine behaviors whenever we want without getting tangled up in a complex family tree of classes.
Okay, so let's get into the weeds a little bit and see how this actually works in code. It's surprisingly simple once you see it. Just think of it like stacking Lego bricks. You start with a base piece, and every new brick you snap on top gives it a new capability.
So the pattern really has four main players. First, you need a common interface that all your objects, both the original one and all the wrappers, are going to share. Second, you have the concrete component, which is just your basic original object. Third, there's a base decorator class whose main job is to hold a reference to the object it's wrapping. And finally, you have the concrete decorators themselves. These are the actual wrappers that add all the cool new functionality. All right, let's walk through a different example to make this super clear. Let's forget about notifications for a second and think about writing data to a file. We're going to start with our concrete component, a simple file data source. Its only job is to write plain, raw data to a file. That's it.
Now, let's say we need to add compression. Instead of changing that original class, we just wrap our source object inside a new compression decorator. Now, the really cool part is that from the outside, this new source object still looks and acts exactly like a file data source. But now, when you call its writeData method, it secretly compresses the data first before passing it along to the original object it's wrapping.
And this is where the magic really happens. You can wrap a wrapper. We take our already wrapped compression object, and we wrap it again, this time with an encryption decorator. So now, when we call writeData, the data first gets encrypted. Then it gets passed to the compression decorator, which compresses it. And then finally, that compressed encrypted data gets passed to the original file data source to be written to the disk. We've built this powerful layered behavior at runtime using 3 simple, completely separate classes.
And chances are you've probably used this pattern before without even realizing it. The most famous example, by far, is in Java's I/O library, where you wrap a file stream inside a buffered in stream, but it's everywhere. Adding scroll bars or borders to a window in a UI framework, wrapping a database query with a caching layer to make it faster. Once you know what to look for, you'll see this pattern all over the place.
You know, a lot of tutorials use pizza toppings as an analogy for this, but honestly, it's kind of confusing because, well, pepperoni isn't a type of pizza, right? A much better way to think about it is like getting dressed. You are the core component. A sweater is a decorator that adds the behavior of warmth. A raincoat is another decorator that adds water resistance. You can layer them in any order, you can take them off, and each one adds a new capability without changing who you fundamentally are underneath.
So, this pattern is obviously really powerful. But the crucial thing is knowing when it's the right tool for the job. Because like any tool, it's got its strengths and it's got its weaknesses.
So on the plus side, it's fantastic for the open-closed principle because you can add new features without ever touching your existing working code. You can add or remove behaviors at runtime, and you totally avoid that subclass explosion we saw earlier. But on the downside, it can lead to a lot of tiny little classes which can clutter up your project. Also, the order you apply the wrappers in can actually change the behavior, which can be a little confusing. And configuring a complex stack of decorators can look a little intimidating when you first see it.
So I want to leave you with this question to think about for your own work. Take a look at your current projects. Is there a place where you're fighting with a really rigid, complicated class hierarchy? And could you maybe untangle that mess by thinking not in terms of what an object is, but what behaviors you can wrap around it? Thanks for watching.